Wind components. Crosswind and headwind or tailwind components. Wind is a vector that, relative to the runway heading, can be broken down into its components. The crosswind component is the contribution of the wind that is perpendicular to the lifting surface, the aerofoil wing. It is calculated using the mathematical sine function. The headwind or tailwind component acts towards the front of the wing in a headwind or towards the rear of the wing in a tailwind. It is calculated using the mathematical cosine function. Let's take a look in the flight computer.
On screen.
First, open the E6BJA app. Enter flight computer mode. Then scroll down the functions list and select the wind components calculator. If we enter a runway, say for instance runway 24, and a wind of 180 degrees at 14 knots, we can see that our headwind is 7 knots and our crosswind is 12.12 knots, rounded down to 12, making the crosswind just at the maximum demonstrated crosswind for a Cessna C-152. If, for experiment's sake, we now change the runway to the opposite end, 06, leaving the wind vector, the direction and speed the same, notice now that our headwind has now become a tailwind. Using a quick rule of thumb, the clock code, to roughly calculate the crosswind component. The clock code can be used to approximate the sine function, and therefore the crosswind component. In the clock code, the difference between the runway heading and the wind direction is rounded to an easy fraction of minutes on a clock face. The ratio of these minutes to a full 60 minutes is then used to determine the crosswind component by multiplying this fraction by the original wind speed. So, for example, for a 20-knot wind, if the difference between the wind heading and the runway heading is 15 degrees, then the crosswind component is 1/4 or 25% of the wind speed, 5 knots. If the difference between the wind heading and the runway heading is 20 degrees, then the crosswind component is 1/3 or 33% of the wind speed, 6.6 knots, 7 knots rounded up. If the difference between the wind heading and the runway heading is 30 degrees, then the crosswind component is 1/2 or 50% of the wind speed, 10 knots, and so on. Note, a 0 degrees difference means 0 crosswind component, and a 60 degrees difference means 100% crosswind component. In this example, it would be 20 knots.
Engage.